Good morning and happy Wednesday. Happy relaxation day. Let's do some math to relax. So, we're going to start with section 10.3, combinations. A combination is going to be a little bit different than what we did yesterday, which was permutation. And the key is going to be to figure out when you're arranging, a combination is going to be arrangement without order, whereas yesterday the permutation had order. There are two different formulas, two different notations. Notice the combination is NCR, or N over R, N choose R, and the formula is N factorial over R factorial times N minus R factorial. So that's a little different than what the permutation was down here yesterday, N factorial over N minus R factorial. Keep in mind, and you should have your calculators out, that both of these formulas are stored in our calculator under the math probability menu. So get your calculators out. Let's get ready to go with some examples. Alright, so here we have an example where we're choosing 2 CDs from 5 CDs in both cases. However, when you take a little closer look, one is buying and one is listening. The buying, when you buy them, you're just choosing them and the order doesn't matter. But when you listen to something, the order does make a difference. If you think of a CD, the songs are ordered in for a specific reason. Again, when there's no order, it's now going to be a combination, 5 choose 2. But when there is no order, it's going to be a permutation. So we need to use our formula for each. 5 minus 2 factorial, which is going to be 5 factorial over 2 factorial times 3 factorial. Make sure you use parentheses. The permutation formula, 5 factorial over 5 minus 2 factorial, which is 5 over 3. Okay, notice the formulas are different. We can, once again, use our calculator to get these by choosing 5 math probability NCR 2, enter, and 5 math probability permutation 2 items to get our 2 answers. Alright, so our answers for combination, sorry about that. We'll get it right here, Mr. Oswald. 10 ways to buy, 20 ways to listen. The permutation should be more than the combination. Alright, let's go. Moving on, we're going to take a look at another example, 2 examples. Okay. So notice here we have how many ways can you choose a committee of 3 people from 12, compared to if instead of a committee we're picking specific officers, which means there's a specific order. So it's NPR on the bottom. When you choose a committee, let's get another E here. There is no order. You just need 3 people. Therefore, it's a combination. Okay, again, keep in mind this one is pretty general. as opposed to the bottom example. You have specific information. So when we're just choosing 3 people, we're choosing 3 out of 12 with no order. Here we're choosing specific positions, so the order is important and you have a permutation. Again, we can use our calculator and put these in. We got to put in the 12 first. Math, probability, combination, 3, or math, probability. Let's come out of there. I have to put the 12 in first. Math, probability, number 2, permutation, choose 3. Again, notice, like we saw in the last problem, we have our answers. And again, the combination, let me see if I can, there we go, 220, 1320, and the combination is always going to be a little less than the permutation. So no order, general, combination, order, specific, permutation. Moving on. Now let's combine ideas here, or take a look at a situation where we have to take 2 choices. Okay? And we're going to end up multiplying those together. So if we read the problem, Samantha is buying paperback books to take on a vacation. How many different ways are there for Samantha to purchase 3 novels and 2 nonfiction books? Okay. However, she's choosing them from 10 and 6. So we're making 2 choices. Okay. First, we're going to choose a novel. And again, it doesn't matter what order she's choosing them. So it's a combination. And there's 10 total novels. And she's got to choose 3. We get the information from the problem, 3 and 10. And for nonfiction, again, the order is not important. 6, choose 2. And when we have multiple steps, we're going to multiply those together for our answer. And over on the right here, I've already done this on my calculator. 10 choose 3 is 120 times 6 choose 2 is 15. And with a little help from the calculator, 120 times 15 is 1800. So our answer would be she has 1800 different choices to make. Very good. And finally, excuse me, let's do a probability problem. Okay, again, the previous problems were counting how many ways. But when we get to a probability question, make sure you are calculating a fraction again, where we put the event that we're looking at over the grand total. Okay? So in this example, which is our last example, we are looking at a bag of marbles. Notice you have 6 blue and 3 green. And the probability is going to be the probability of drawing 3 blue marbles from the bag and 1 green marble from the bag. Okay, that's our event on the top. and on the bottom we have to do our total. So if we pick 3 blue and 1 green, we have a total of 4. Again, I have 2 events that I have to multiply together. I'm choosing 3 blue. No order is necessary, but there are 6 total blue. I'm choosing 3 times I need to choose 1 green out of 3. Excellent. And in the bottom I need the total, so I just add these two together. There are 9 total marbles, and I'm picking out 4. Okay, now if I use parentheses, I can enter this in on my calculator. So let's finish up here. Clear our calculator out. Parentheses. Okay. 6 math probability combination. Math probability combination, choose 3 times 3 math probability combination, choose 1, parentheses, divided by parentheses 9 math combination, choose 4. So I use parentheses on the top and I use parentheses on the bottom. And so there's our answer. Folks, it's like the Super Bowl. And remember, our answer we want to write in decimal form, rounded to the nearest tenth. So a 0.48 or 48% chance of drawing a 3 blue marbles and 1 green. Awesome lesson. Excuse me. Now we can relax by doing page 647, section 10.3, assignment A, numbers 8 through 39. Relax and enjoy.